All right, let's take a look at this and go through this, get all the answers to this and how you do these problems. Um, number one, exact value, the sign of negative 3 pi over 4. Negative is in the clockwise direction. Pi over 4, 2 pi over 4, 3 pi over 4. Gets me right down the middle of the third quadrant. Drop a perpendicular to the x-axis. Because it's right down the middle, this is a 45-degree angle, right? Pi over 4 angle there. So that side and that side are going to be the same length. Call them both -1. Negative because you're in the third quadrant. And then this is hypotenuse is radical 2. So -1 over radical 2 would be the sign y over r. Okay. I said exact value. Just give me 0.707, now 0.707 is not exact. So something like that. This one, most people got this. I've got an angle in standard position whose terminal side is on the line y equals -4x. So y equals -4x goes from the second quadrant down into the fourth. And I said my angle is there in the second quadrant. So I need a point on that line. I chose x coordinate to be -1, and then you calculate that y would be 4. And so y over x would be 4 over -1, and the tangent is -4. You could choose any point on that graph, any x, then this would be -4x, and the slope and the tangent would be -4x over x. Cancel the x's out, and you get -4. It doesn't matter which x you choose. But cancel those x's out because it doesn't depend on x. I'm going to go fast. If you have any questions, please ask them in the discussions or send me a message or something. Find all the angles between 0 and 360 that satisfy the equation tangent of theta is 0.6. Well, one of the answers, the simplest one, is just take the inverse tangent of both sides. So you get the inverse tangent of 0.6. That's just under 31 degrees, 30.96. If you're doing it in radians, it's 0.54. Okay. The thing is, that's a first quadrant angle. That's, tangent is 0.6 over 1. So you're looking at that angle. It's 31 degrees. But there's another place down here in the third quadrant where you have -0.6 and -1 to get the tangent to be positive 0.6 again. So you get this angle down there. So add 180 degrees onto what you were. That would be just under 211, so 210.96. Or if you're doing it in radians, add on pi, so 3.682. I don't know if anyone actually did this in radians, but it's there. This one, person standing on a cliff 200 feet tall, sees a boat out on the water here. The angle of depression is 3 degrees. Depression is from the horizontal down, not from the vertical up. Anyway, it's this angle, 3, which turns out to be the same as this angle over here, 3. So you're looking for x. If you put the 3 there, you probably got this answer of 10.48, which is essentially you did everything right except for not knowing what the angle of depression means from the horizontal down, that one. Anyway, with it here, 200 over x is the tangent of 3 degrees. So solve for x. X is 200 divided by the tangent of 3 degrees, and you get this 3,816.277. It's quite a bit different than 10 degrees. Sorry, 10.48. So there's that one. Number 5. Theta is in the first quadrant. Then the sine of theta is a over 3. So first quadrant, sine opposite over hypotenuse a over 3. I can use Pythagoras to get the square root of 9 minus a squared, but I don't immediately need that. I'm asking for the cosine of 180 minus theta. So where the heck is 180 minus theta? If you turn through 180 and then back up theta, then you've got this triangle over here in the second quadrant, which looks a lot like the one in the first quadrant, because this angle here, this theta, is the same as that theta, and so I can say a over 3, which means that this is also square root of 9 minus a squared, but because you're in the second quadrant, that x-coordinate would be negative. So the cosine is x over r, negative square root of 9 minus a squared over 3. A couple people do some really bad algebra and, take that square root of 9 minus a squared and say that it was 3 minus a. But it doesn't work that way. Look, square root of 25, square root of 16 plus 9. If you just say that's the square root of 16 plus the square root of 9, then that would be 4 plus 3, which would be 7. You're telling me the square root of 25 is 7? No. Why does that not work? Because the square root does not distribute over addition, nor does it distribute over subtraction. Just leave that as it is. it does distribute over multiplication, right? Square root of a times b is the square root of a times the square root of b, but not plus, not minus. Anyway, uh, number 6. Number 6, I've got an angle whose sine is equal to -1/2. It's either this angle, it's either down here, -1/2, or -1/2. I know I'm in the third or fourth quadrant to get the sine equal to -1/2. But they say I want the tangent to be positive. Well, here the x-coordinate is positive, so the tangent would be negative, and here the x-coordinate is negative, so you have negative divided by negative, that would be positive. And so I want this angle over here, that one. Right? And then you might recognize as the 1, 2 square root of 3 triangle, negative square root of 3 over there. So this is like a 30-degree angle, or a pi over 6, depending if you're doing it in radians. So you might say, hey, that's 30, so that's 180 plus 30, so 210. Or you might have said it's pi plus pi over 6, which is 7 pi over 6. 7. 7, 7, 7. Yes, here we go. The triangle below us, I find side length A. There's a right triangle. The hypotenuse is down here. 8 is that side there. So A divided by 8, that's opposite and adjacent side for 27. So tangent of 27 is A divided by 8. So A is going to be 8 times the tangent of 27, which turns out to be 4.07. Number 8, the radius of a circle, central angle 20. Yeah. The formula we're dealing with here is S equals R theta. I tell you the arc length is 10, the angle is 20, what's the radius? So I give you the arc length, I give you the angle, what's the radius? The problem is I had some people just say, hey, 10 is equal to R times 20, so they divided by 20 and they told me that the radius was equal to 1/2. Now look at this, 20 degrees. This is about a 20-degree angle here. This is 10. Is there any way that that is like the half? I mean, this is 10. That's a half? No, this is obviously more than 10. This is bigger than 10. So why does that not work? Well, it doesn't work because this formula only works when theta is measured in radians. So take the 20 degrees and turn it into radians. Pi over 9. 10 equals R times pi over 9. Then divide by that, and you get 90 over pi, which is 28. Notice that's about, well, 2.8 times as big as 10. It's, it's 10, 20, and 8 more, 28. Got to be in radians. Got to be in radians. Number 9. Simplify. I'm hoping that these problems all look fairly familiar to you. Distributive property. I'm going to multiply that in there and there. Cosine of theta times the secant of theta. Well, secant is 1 over cosine. So cosine x times 1 over cosine x is 1. That's that one right there. And then the cosine x times the cosine x is cosine squared x. But 1 minus cosine squared x is sine squared x. So that's what I was looking for. Number 10. Most people did pretty well on this one. I give you that angles A is 20, B is 50, and side C is 500. First thing I did in this problem was I said, hey, if I know two angles, 180 minus both of those angles would give me the other angle. So I know that that's 110. That now lets me set up the law of sines because I have an angle and the side opposite known. I have this side that I'm looking for and a known angle. So A over the sine of 20, A over the sine of 20 is 500 over the sine of 110. Solving for A, I get this, which is 181.985. Like I said, most people did just fine with that. Number 11 has a little more difficulty because some people got hung up on the ambiguous case. Given angle A is 30 degrees, side B is 50, side C is 40, find angle B. Okay. Now, a couple things that went wrong right away. Some people said, oh, you got a 30-degree angle. This is a 30, 60, 90. No, it could be a 30, 42, whatever else it takes to add up to 180. You'd have no idea what these things are. Likewise, some people saw the 4 and the 5 and said, oh, this is a 3, 4, 5 right triangle, only times 10. So they said the other side here is 30. It's like, no. This determines what the triangle is. The information, 30 degrees, 40, and 50, precisely determine the rest of this, and because of the law of cosines. So the law of cosines says that a squared should be 50 squared plus 40 squared minus 2 times 50 times 40 times the cosine of 30. So a is the square root of that. That's this calculation here. It turns out to be 25.217 something. Then, once you know a, you know all three sides, you could use the law of sines to find another one of the angles. The problem is the law of sines, because of the ambiguous case, will sometimes get the answer wrong. And the only time it gets the answer wrong is when you're trying to use the law of sines to find an angle. Actually, when you're trying to find the biggest angle. If the angle has any possibility of being bigger than 90 degrees, then you run the risk of getting the wrong answer. Because the law of sines will never give you an answer bigger than 90 degrees. It always gives you something smaller than 90 degrees. So solve for an angle that you know is smaller than 90 degrees. The three sides that I know, 25, 40, 50, 50 is the biggest one, so the angle opposite it is the biggest angle. That's the one that the law of sines might get wrong, and does get wrong. So solve for solve for angle C. Sine C over 40 is sine 30 over A. A was known as 25 point whatever. All right, I use my calculator and I carry all the decimal places. So anyway, sine of C is 40 times sine 30 over A, and then so you take the inverse sine, and C turns out to be 52 point something. So then you can get B by subtracting 180 minus 30 minus that 52 point something, and you end up with 97.522. Notice, bigger than 90 degrees. If you came up with the answer of 82.477, that tells me you used the law of sines to find angle B, and it gave you the supplement of the correct answer. 180 minus your answer is the correct answer. Right. The law of sines, when you're solving for the biggest angle, is fraught with peril. Fraught, I say. Number 12. Draw the graph. First of all, you got a graphing calculator. You ought to be at least able to get it into close to the right spot. I see people drawing it down here. It's like, did you not even double check? You have the calculator. But then at the same time, I have some people just drawing in the calculator, and I can tell they don't really know what it looks like. I want to be able to see that you really know what it looks like. So here we go. First thing I do is I factor this 2 out of here. So 2 times x minus pi over 6. This lets me see the horizontal shift. Pi over 6 to the right. And I'll write that down here. Also, the 2 lets me see that the period is 2 pi divided by that 2. So the period is going to be pi. The 3 out in front is the vertical shift of 3. So it's going to be up 3. And the 2 here is the amplitude. Amplitude 2. The minus sign is flip it upside down. So I got an upside down amplitude 2 sine curve, shifted up 3, moved over pi over 6, period is pi. So the pi over 6 and up 3, I'm going to start right here. Now let me point something out. I said label the axes, so I can tell that you know how big your periods are. If you don't say what each unit is worth here, then I don't know if you're plotting it accurately. But I chose to make 1 unit here pi over 6, which means 2 units is 2 pi over 6, and 3 units is 3 pi over 6, 4 pi over 6, 5 pi over 6, and 6 pi over 6. That's where I get to pi. Right? I see people do this all the time. It's like, how do I get people to stop doing this? You say this is pi over 6, and then you stick pi like right here, like 4 things in. It's like, what? I mean, when you set a particular length, then everything should be that same length. If that's pi over 6 from here to there, then this is pi over 6 from there to there. So that's 2 pi over 6. And from here to here is 3 pi over 6, which happens to be pi over 2. 4 pi over 6, 5 pi over 6, 6 pi over 6. 2 pi is all the way out here. I don't care what you set it at, but once you set your scale, be consistent with it. So in the y direction, I use the scale as just 1, 2, 3. Right? So the sine curve typically would start at the origin, but because it's been shifted over pi over 6 and up 3, I'm going to start right here. And it's an upside down sine curve, so I'm going to start going down. The period was pi, so from my starting point, I'm going to move over pi to get to the end. Note that's 1, 2, 3, 4, 5, 6 pi over 6s. Halfway in between, it should still be in the middle there. At the quarter point, I'm going to be down because that's minus sign, the amplitude, and at the 3/4 point, I'm up. So then I just continue the